My name is Yujia. This is our Lab4 demo. Our team has three group members, me, Heran, and Talha. I'm going to do a quick review of the design source as well as the simulation. Unfortunately, we wouldn't be able to show you the actual implementation on FPGA board because pushing to the board wasn't successful, but I will try to show you we did as much as we can. So if we look at this if we look at this module, it only has one submodule, which is the ALU, that can help us increment seconds, minutes, and hours using the adder that we used before. Other than that, everything else is in this one giant file, and I will explain everything. So I declared these inputs and outputs. So I think I will explain them one by one. So switch mode button is basically a switch that will help me transition between different states of the more state machine. Think of it as a input of the finite state machine, and the detail of the FSM will be shown later. I also have a data in switch. This is 1-bit switch that will allow the user to send in 1 bit at a time, which represent the binary version of different digits of hour, minutes, and seconds. So what I did was I declared a variable called store. This is a store variable. It has 20 binary digits, and so the first 2 digits will encode the binary version of the most significant bit of hour, and the next 4 digits represent the least significant digit of hour. So going along with this pattern, I have this giant variable to store everything that the user wants to send in. So for example, if I want to send my time to be 23 in 24-hour format, like 11 p.m., then I will put in 1 0 for the first bit and 0 0 1 1, because 1 0 is 2, 0 0 1 1 is 3. That represents 23, what I want for the hour. Then going back to the inputs that I declared, I also have 2 inputs that will allow the user to toggle between 24 and 12-hour format, as well as AM and PM. For flip-flop design, clock reset are required, so these are also included. The last 2 inputs that I have are alarm on and start alarm. So these are basically switches or buttons that will allow the user to turn on the alarm mode, as well as a switch that can stop the alarm if you want it, or when the alarm sound is off. So for my outputs, I have a alarm sound variable. This is a signal that will be high if the alarm is if the alarm set by the user is equal to the actual time. And all of the rest outputs are just the final display of the clock or the alarm of each decimal version of the hour, minute, and second shown on the screen. So depending on the user's preference, it could be either display of the current time or display of alarm. So we don't have to explain the details of declaring different variables. These are just necessary because we wrote different modules. But I will try to explain to you what LD time, LD alarm, and LD set format is. So part of this code is inspired by the FPGA for students. I borrowed some ideas from that website. So these three variables are, think of them as Boolean variables that will be 1 if you want to show the current time. So if LD time is equal to 1, then we will set the current time to be the time required by the user. If the LD alarm variable is 1, then the alarm time should be set to the values that is specified by the user. And the last one is LD set format. So similarly, if this is 1, then we will transition into a state that will allow the user to set the time format. So the way I'm going to switch between different states and turn these variables on or off is through a finite state machine that I wrote here. This is inspired by the homework 8, or the most recent homework, where we have to have 4 modes for a time alarm system. So this is exactly the same thing. You have to release the button in order to transition into the next state, while if you are just holding the button, then you will stay in the same state. So you can look into the detail of this finite state machine later. The important thing here is the output of this finite state machine are just different mode. So these mode ultimately will control the 3 variables that I just talked about. And then how are we going to create the the passage of time in nature? We will use a clock divider. So if we are able to push to the board, then this clock is actually the default clock in FPGA. But we will use this clock and divide that by this number. So because that is a very high frequency clock, so by dividing this number, we'll be able to create 1 second. So if the positive edges occur that many times, then we know in nature 1 second has passed. That's the idea behind that. We also, these are just the clock operation. As you can see here, I can turn LD time, LD alarm, and LD set format on or off in order to allow the user to set see current time, set alarm time, or set time format. And these are this section governs the output of the clock. This is just telling you how would I convert the counter. So there's a counter in the last block of code which will count how many seconds have been passed. So we will convert the counters into actual seconds, minutes, and hours, and then finally convert everything into the 7-segment display format. And this is just a tiny section for the alarm operation. Just very easy. If the alarm time is equal to the actual time, then the alarm sound signal will be high. And then if you want to stop the alarm, then you can just push the stop alarm button to make it stop, so no more sound. Right now, we are going to show you the simulation. So while it is doing the simulation, I forgot to show you the test bench. Our test bench, we will alternate the clock to create positive and negative edges. to mimic the passing time. Then we will use the switch mode button to switch between different modes. We will go from current time to set time mode, and then this is pretending I am the user, putting in different numbers for the time. Then I'll release the button and go into the next state, which is set alarm mode. Again, setting a different alarm. Set it to 12 a.m. Now I enter the current time, waiting for the simulation to go until the current time is equal to the alarm time. Then the alarm signal should be on. But for some reason, I have no idea why. So I've been trying to extending the simulation time to 10,000 nanoseconds, but still I only get one display, like one snapshot of the clock, as you can see here. Hour, minute, and seconds are not changing. I don't know what is happening. There are some there are changes in the second. I don't know if it's because I didn't have enough simulation time, or we will work on improving this later. Thank you.